In today's lesson, we are going to look at rates. A rate is a comparison of two quantities measured in different units. For example, a growth rate is 6 centimeters every 1 month. You can see here that centimeters and month cannot be canceled out, so I must have my units. And that's why we could write it as 6 centimeters per month. Whenever we have the per or the little line like that, it means per one thing, right? If there's no number there. So this is a rate. We need both units because they cannot cancel out. Whereas in a ratio, we had 2 centimeters as compared to 8 centimeters. Since the ratios are the same, we know that in proportion, it is a 2 to 8 or 1 to 4 ratio. I could use any unit and it would be proportion. I could use 1 inch as compared to 4 inches. It just means that this one is 4 times larger than that one, right? Whereas a rate is different. It's not about a scale factor, an enlargement, or a reduction, right? This is about how fast something is changing as compared to something else. Fuel efficiency is another rate, 6.8 liters per 100 kilometers. Heart rate, how many beats per minute, so those are different examples. Speed is a special rate. We use it a lot. Speed is distance as compared to time. So using the speed, if we had 100 kilometers per 2 hours, we could write that as 50 kilometers per hour. Using the speed formula, we can also create, now that we know our algebra skills, 3 different formulas. For example, if I multiply both sides by time, these times will cancel, and my other formula could be time multiplied by speed equals distance, right? And if I divide both sides over here by speed, right, so I divide the left side of the equation by speed and the right side of the equation by speed, the speeds cancel, and we have our third equation, which is time is equal to distance divided by speed. So we have time equals distance divided by speed. We have time multiplied by speed equals distance. And last but not least, we have speed equals distance over time. Okay, some people, to help you remember these 3, use a little memory tool where distance is on the top, speed and time are there. The top distance is equal to speed multiplied by time. Speed is equal to distance divided by time, and time is equal to distance divided by speed. So it's a little memory tool to help you remember those 3 if you need. Okay. What is a unit rate? A unit rate just means the second term is 1. Okay, it means as compared to 1. Right? So 60 kilometers per hour, as I talked about earlier, just means I have 60 kilometers every 1 hour. $5 per liter means it's cost $5 per 1 liter. Right? So you can always make it a fraction. You just put the number 1 on the bottom. We like unit rates because it makes it easier for comparison. If you're going to the grocery store and you want to know what's a better deal, well, if it's buy 5 and you pay this price, well, if you divide by 5 and find out how much it costs per 1, you can compare the 2 things, the 2 deals, if the other one was buy 3 for this price. Okay? So they're great for comparisons. So remember, a ratio has common units so that they can cancel. A rate has different units. Let's practice this one. Let's find the unit rate if Brandon can run 150 meters in 25 seconds. So we would write it as 150 meters, distance divided by time gives us our speed. This will be his speed. So then I want 1 on the bottom, so I have to divide the bottom by 25 to get 1. So whatever I do to the bottom, I do to the top. So I'm going to divide 150 by 25, and I'm going to get 6 meters. And I'm going to divide the bottom by 25 and get 1 second. Or in other words, I can write his speed as 6 meters per second. We can compare prices, like I said earlier, by finding the unit rate. Now, if I was to find the unit rate for the first one and say, okay, well, $1.69 per 414 milliliters, if I divide 1.69 by 414, I get a really, really, really small number, which is like 1,000th of a cent, right? So it's not really realistic to find a unit rate here. So when I say find a unit rate, it doesn't have to be per 1 milliliter. It could be per 100 milliliters, which makes sense because 1 milliliter is just an eyedropper of a droplet of water, right? So that would be silly to find the price per that. So maybe find it per 1,000 milliliters or per 100 milliliters, etc. And remember, 1 liter is equal to 1,000 milliliters. Okay, so you can think about the size of a liter. If you think about that inside your fridge, it would be the size of one of those creamer, the tall creamer bottles. Or if you could, a bigger milk carton would be 2 liters, right? That would be a 2-liter container. Or if you had the jug of milk, it would be a 4-liter container, right? So 100 milliliters is still quite small. So it's like a little less than half a cup. So if I wanted to find how much it is per 100 milliliters, well, if I divide by 414, that would get me to 1 milliliter, but then I'd have to multiply by 100, right? So I have to divide by 414 and then multiply by 100. Whatever I do to the bottom, I do to the top. So let's find out what it is per 100 milliliters. So $1.69 divided by 414 times 100 is 0.408. So it's about 41 cents for every 100 milliliters. So that's for A. Let's check out B. B is 9. Sorry, I'm going to do the money on top. I always do the price per something. Right, so you can find out how much it is per 1 thing, per 10 things, per 50 things, etc. And I have 949 milliliters. So again, I'm going to create it out of 100. To get to 100, I'm going to divide by 949. That gets me to 1, and then times by 100. So I'm going to do the same thing to the top. I'm going to go 299 divided by 949 and then multiply by 100. And I'm going to get 0.315. So it's about 32 cents per milliliter. So that's a lot cheaper than A. And let's take a look at C. This is in liters and those are in milliliters. So we have to first change this to milliliters by multiplying by 1,000. So when we multiply that by 1,000, we have 1,890 milliliters. So we're going to have $5.49 per 1,890 milliliters. And again, we want to find out how much per 100 milliliters. So I'm going to take my $5.99, divide it by 1,890, and then multiply it by 100, and I get 0.317. So very close. So good thing I added those extra decimal places, because if they were both 0.32, I wouldn't know much difference. So really B and C are pretty close. Either one of those are a great deal. If you needed more orange juice, I'd go for C. If you didn't need as much orange juice, I'd go for B. But A is quite a bit more expensive. So the best, though, if you really, really, really want to be super detailed, this would be the best buy right there. We can compare density using rate. Density is how many people live in a certain area. So if there's lots of people in a small area, it's dense. If there's less people in a large area, it's not as dense. So let's take a look at Canada's density. So these numbers are old, but they're good estimations. The population is 31 million approximately for quite a large land area. So to find the density, we would take our 31,310,006,000 and we would divide it by 9,220,000, and we see that it is approximately 3.4 people per square kilometer. Okay? So a kilometer by a kilometer area, right? 1,000 meters by 1,000 meters. They would be about 3.5 people per that space in all of Canada. Let's look at the United States. So we have 272,640, and again, these numbers are not accurate, divided by 9,159,000, and we get 29.8 people per square kilometer. So you can see from this that the United States is a lot more dense than Canada by comparing the people per square kilometer, or the density of the population. All right, Marlene can run 4 kilometers in 30 minutes. Can she run 6 kilometers in 45 minutes? Oh, this is a bad question. So let's just change this. Let's change this to a different person. Let's say Joe can run 6 kilometers in 45 minutes. Who's faster? Well, let's take a look at Marlene. She is 44 kilometers in 30 minutes. And Joe is 6 kilometers in 45 minutes. So we could find out how far they can go in 1 minute and compare that. But again, that's, you're going to get lots of decimals. So let's find maybe a common denominator, or maybe, hey, I can see 15 is a nice easy number they can both get to. It doesn't have to be per 1, right? So if we can make it per 15, so if I can divide by 2 and divide by 2, Marlene can go 2 kilometers every 15 minutes. And here I'm going to be divide by 3 and divide by 3. Hey, what do you notice? You notice that they are the exact same speed. Okay, so they are running at the exact same speed. They are both going at 2 kilometers per 15 minutes. On a 1,035 kilometer trip from Calgary to Abbotsford, Dave's dad drove at 85 kilometers per hour. On the trip back, there was construction, and his speed was 75 kilometers per 1 hour. Okay, what is the difference in time? What's time again? Time is going to be distance divided by speed. So if we take the distance they're traveling and we divide by the speed, so maybe I shouldn't have written it like that. So if for the trip going out, we know that we are going 1,035 kilometers at 85 kilometers per hour. If we want to find our time going at this speed, then we can just divide. 1,035 divided by 85 is approximately 12.2 hours, right? 12.2 hours. Why do the kilometers cancel out? Because if you have kilometers and you're dividing by kilometers per hour, it's the same thing as multiplying by the reciprocal. So you have kilometers multiplied by hours per kilometers. If you take the reciprocal of the units, you can see how my kilometers cancel out and we're left with hours. All right, so 12.2 hours, okay? Let's take a look and figure out the time going at 75 kilometers. It's the same distance going back, so we have that same distance, but now we're at 75 kilometers per hour. So I go 1,035 divided by 75, and I get 13.8 hours. So what is the difference in time? Well, if we subtract the two, I get 1.6 hours. That's the difference. That does not mean 1 hour and 6 minutes. That does not mean 1 hour and 60 minutes. 0.6 hours, what does 0.6 hours mean? Well, 0.6 hours is out of 10, right? That's 0.6 of an hour. So if I want to find out, instead of being in hours, and I want to change this into minutes, I have to find out what 0.6 of 1 hour is. Well, I don't want an hour, I want minutes. So I have to convert 1 hour into 60 minutes. So you just change whatever you want it into. And we know when you're finding a fraction, 0.6 or 6/10 of something, it's the same as multiplication. So you can go 0.6 multiplied by 60 minutes to find out, to convert that into minutes. So 0.6 times 60 is Oh, that's 36 minutes. So this is going to be, the difference is going to be 1 hour and 36 minutes. Okay, so that's the tricky part, how to convert a part of an hour into minutes. You take your 0.6 and you multiply it by 60, right? On average, a certain baseball player has 212 hits in 1,000 times at bat, right? So we say their batting average is, well, if you have 212 hits for 1,000 at bats, if we divide that and find out how much it is per at bat, and I divide by 1,000, we give them what we call a batting average. Their batting average is 0.121, okay? Or in other words, they can hit about 12 times for every 100 at bats. Or we say they're batting, they have a 12% batting average, right? But typically batting averages are written per 1,000 at bats and changed to a decimal. Okay? Describe 2 different strategies you can determine how many at bats he's likely to get at 400. What could one strategy be? Well, I could take this like we did before and say, well, I know I have 1,000 at-bats and I want it to be 400. So we could say, I want to divide by 1,000 to get to 1 and then times by 400. So I'm going to take 1,000 divided by 1,000 times 400. So I'll do the same to the top. 212 divided by 1,000 and then multiply by 400. And I get 84.8, so you obviously can't go up to bat 0.8 of a time, so I'd round off to say about 85 hits would be how many times they should hit based on that batting average if they get up to bat 400 times. What's another way we could do it? Well, we could just use our equivalent fractions, right? We could say, how am I getting from 1,000 to 400? Well, I'm getting smaller, so I'm dividing by something. But what am I dividing by? Well, I'm dividing by whatever 1,000 divided by 400 is. Oh, I'm dividing by 2.5. So do whatever I do to the bottom, I do to the top. So I could take my 212 and divide it by 2.5 and get, I get the same answer, which makes sense because they're equivalent fractions. So you could create a unit rate and then multiply by what you want, or you could find out what you're multiplying or dividing by and do the same to the top and the bottom.